All right, for this bell work, we got 18 equals 9 times x. And to solve this one, it's just like what we saw in the last assignment and classwork. So what we're going to do here is we don't want 9x's. What we really want out of this is 1x's, okay? Because as soon as I get this coefficient to be a 1, I can make it a phantom 1. I don't want the coefficient to be anything but 1. I don't want the coefficient to be 9. I don't want it to be a fraction. I don't want it to be negative. I just want it to be a phantom 1. Or a 1, because then I'm going to make it a phantom 1. There we go. So I'm going to show this 9, and how do I make it a 1? Remember, that's one of our principles of equality last time. It's either addition, multiplication, or division. So I'm going to divide 9 by 9 to make 1. But remember, our principles of equality say if you're going to do it to one side, you must also do it to the other side. So I got to do 18 divided by 9 as well. And remember, this line is going to bring down our equal sign. So 18 divided by 9 is 2. Now that I do have 1x, I will make that a phantom 1x. So it just shows x equals 2. But last thing I want to do on this is just to make sure it is true, the equation is true, when I replace x with 2. So I go into my original equation. I'm going to rewrite it. 18 equals 9x. But now I'm pretty sure x is 2. So I'm going to replace the x with 2. All right, so I'm going to check for truthfulness here. And I find when I do 9 times 2, I do get 18. And 18 is 18. That's true. Okay, so since that's true, I know that x equals 2. That would be my solution to the original equation. Okay. Now, if by chance I found that I got like 17 equals 18, I know that maybe I did this calculation wrong, or maybe I divided wrong or something like that. But I'd have to go back and check to make sure or find out where I made my mistake. Right now, x equals 2 is the solution. Here's our objective for the day. I can solve equations with 2 principles of equality. And so far, we've gone over 4 different principles of equality. 1 for addition, 1 for subtraction, 1 for multiplication, 1 for division. Okay, but we saw between the last 2 lessons, we use addition and subtraction to make zeros, which eventually become phantom zeros. And then we use, from the last lesson, we use division and multiplication to make phantom ones. Like on the bell work, we did divide on both sides in order to make a coefficient that is a phantom 1. Remember, that's the important part. We're forcing those coefficients to be phantom 1. Anything else that's being added or subtracted to our x's or variables will need to become phantom zeros, essentially. So take 30 seconds and copy this down, please. So just remember equations versus expressions. An equation is a comparison of 2 expressions. Sometimes they're just numbers by themselves, right? Like you could say 10 equals 10. And that's an expression. 10 is by itself an expression, and this 10 is also an expression, okay? But they're 2 separate terms on separate sides of the equal sign, okay? So remember, we also seen that you could take that 10, and instead of showing it as 10, you could also show it as 15 minus 5. And now, see, this is looking more like an expression that we would expect with some operations in the expression. But remember, an individual term by itself can be an expression. In addition to that, some expressions just have letters for the numbers right here. And so sometimes our equations may look like this, okay? But the main thing with equations is that somewhere in there should be an equal sign. And if there's a variable with the equal sign, our objective then is to find values of x that make the equation a true statement. That brings us to solutions. That's what a solution is, just like we saw on the bell work. When we find a value of x that makes the equation a true statement, then we know that is the solution to the equation, okay? And that takes some checking, just like we've seen not only on the bell work, but pretty much for the last 2 lessons, right? We go back to the original equation. Whatever value we think would make x, that x would be to make the equation true, we plug it back into the original equation and then check for truthfulness. Because if it's false, we know we made a mistake somewhere, right? So like in this equation that we just barely saw, 15 minus x, if it were to equal 10, the only value of x that would make this true is if you made x equal to 5. So that means you would be replacing this x with this 5, and then that would be the solution, okay? Now remember, with those solutions, there's lots of non-solutions that you could replace x with to make it false. But this is the only value we have right now that would make this true, this original equation, okay? But it has to make the original equation true. So here's our principles of equality. We've got addition, subtraction, multiplication, and division. And remember, the whole idea with principles of equality is just whatever you do to one side of the equal sign, you must do to the other side of the equal sign. Okay? Whatever you do to one side, you got to do to the other side, no matter what operation you're using, whether it's addition, subtraction, multiplication, or division, right? And so if we were to look at an equation, even if it was just like 10 equals 10, like this, I could say, hey, look, with my principle of equality, if I wanted to add or subtract whatever I wanted, like 5 here, as long as I do it to both sides, I maintain equality. Because 15 does equal 15. See that? And it wouldn't matter what I added or subtracted, multiplied it or divided it, it would still give me a true statement, okay? Now, along those lines then, there's more purpose than to just randomly do things to one side and the other side, just like we've seen with the last 2 lessons. Remember, addition and subtraction, if we're going to be using these 2 principles of equality, this is when we're going to make phantom zeros. Really, the values that I'm going to be making phantom zeros is anything that's being added or subtracted to my variables, usually x's, but it could be some other letter, v's, n's, doesn't matter. But I will make these phantom zeros. Really, what it comes out to is like a plus 0. So like if you had 10 plus 0, like this, there's no reason to really show that plus 0, so sometimes we make it a phantom plus 0. It's still there, you just can't see it, okay? And then multiplication and division, that's what we saw last time. If we're going to be using multiplication and division, principles of equality. So remember, that means if you're multiplying on one side, you got to multiply on the other side. If you're putting it there, okay, or even divide. But if we're using multiplication or division, this is when we make phantom ones. Now, the ones that we're talking about here, they don't start out as ones or phantom ones. They will actually show the ones. But like we've seen in the bell work, after we show that 1 as the coefficient of x, then we make it a phantom 1. Okay, so but the idea here is that the coefficient of whatever the letter is will become a phantom 1. Now this last note down here with 2-step equations, when it says 2 steps, it just means 2 principles of equality, which is why that's part of our objective, okay? You need 2 of these principles of equality. Usually one of each, either you're going to make a phantom 0 and then a phantom 1, and it usually happens in that order, by the way, okay? So you're going to make your phantom zeros first, and then you're going to make your phantom 1s second, all right? And I'm not guaranteeing that it will always happen that way, but for now, this is pretty much what we're looking at. And keep in mind, just like we've seen from the last unit, eventually we're going to be doing some distribution and combining like terms to solve equations. But right now, we're just focused on our principles of equality, because if we can get these down and we can distribute and combine like terms, the rest of it goes pretty good, okay? So here's our first example. Negative 8v plus 12 equals negative 84. Now, the first thing I do want to do on this one is, remember, we're going to be using principles of equality here, okay? And remember, I don't want to show anything added to my v's in this case, which means that negative 8v, what I would really like to do is just drop it as negative 8v. And you could say, well, you're going to be adding 0 to it, but remember, we don't want to actually have to show that plus 0, okay? Right now, though, it's adding this 12. Garbage. We don't want to show adding 12. We want to show plus 0. So how do I make a plus 12 a 0? I would have to subtract 12. Okay, now I put this minus 12 here, which means I kind of added that to the expression. So if I do it to one side of the equal sign, I must also do it to the other side of the equal sign. So this line brings down the equal sign. That's good. But negative 84 minus 12, you can put that in the calculator if you need to. You're going to get negative 96. Okay. So now that I got negative 8v equals negative 96, remembering that there is the plus 0 there, and I talked about this 2 lessons ago. If I make a phantom 0, I kind of like to show the 0. It's not a circle. I'm not like circling these. That's a 0. I just don't want to have to show it in my new equation, okay? But now I got negative 8v equals negative 96. And what I really want out of this is to have just one v equals some number, okay? Because if I can get one v, then I can make this one a phantom one, okay? So the negative 8, how do I make that a phantom one? Well, to do this, I'm going to have to divide by negative 8, okay? But again, I put that negative 8, divide by negative 8 there. So if I do it to one side, I'm also going to have to do it the other side. And negative 96 divided by negative 8 is 12. It's positive 12. See, so this is my solution right here, or it should be my solution. 1v equals 12. But again, now that I have my coefficient of v as a 1, I'm going to make it a phantom 1. So I don't have to look at that 1 garbage, okay? Now this should be our solution, but I do want to check just to make sure that it is actually the solution. So I'm going to go back to my original equation here. And I'm writing this out, right? Negative 8v plus 12 equals negative 84. And what I'm doing right now, I'm checking for truthfulness, right? So a lot of students, they still ask, hey, Mr. Sal, is this the right answer? Well, I'm going to ask you if it is. I'm just going to ask you back if it is. Because if you do this process, you'll know for sure if your answer is the actual solution, if it's the answer, okay? So you should always be doing this process. Also, some of you guys have been asking questions that it could be solved if you were just writing this stuff down. So if you're not going to write this stuff down, then don't expect to learn very much or remember very much of this, okay? You guys need to be writing this stuff down. I'm not just putting this on the board for your entertainment. And if it's entertaining to you, it's kind of weird. So I'm going to take the v here and I'm going to replace it with 12. And I'm going to check for truthfulness, okay? So that means I'm going to put a question mark over the equal sign because I don't know for sure if this is true or not yet. Then I'm just going to solve, okay? So I'd say negative 8 times 12, that'd be negative 96. And then I will still add my 12 there. And when I do negative 96 plus 12, I get negative 84. Now remember, this was supposed to equal negative 84, which it does. This right here is a true statement. Which means that v equals 12, that is the actual solution to the original equation. Now, something else you may have noticed when we were checking, right? Remember when we did negative 8 times 12 here, and we got negative 96? That was built in to the work that we had already. Remember, negative 8v equals negative 96? Well, we just did negative 8 times v, and we got negative 96. That's why this is showing, it's kind of repeating these values. We went forwards, then we went backwards to check, okay? And then negative 96 plus 12, it was negative 84 here in orange. That was this negative 84 that we had started out with, okay? But we checked to make sure that this is, if I replace v with 12, it gave me a true statement. This is a pretty crucial step here because some students don't do this, which means, I don't know, maybe you like to gamble. I don't know. But in any case, again, there's no need to ask if your answers are true if you're checking these values, which it's not hard to do. You could have just plugged this directly into the calculator, negative 8 times 12 plus 12, and you got negative 84, and then the calculator would have done that work for you. But I recommend showing it until you get a little bit more experience with that. Okay, so once again, the process here, we made a phantom 0 here, and then we made a phantom 1 right there. Remember, the 1's still there, you just can't see it. All right, so the process is going to work pretty much the same way on this one, right? So I'm going to take this negative 4x minus 3. It equals negative 71. But right now, again, what I would really like to do is just be able to drop this negative 4x, which means that this is a negative 3 right here, term. The term itself is a negative 3. I don't want it there. What I would really like to have there is just a plus 0, right? So how do I make a negative 3 a 0? I have to add 3. But since I put that plus 3 there, I got to do it the other side as well. That's our principle of equality. So what happens here? Well, yeah, we didn't do anything with the negative 4x's, so I got to drop this negative 4x. But negative 3 plus 3 here becomes a 0. Now remember, this is a plus 0 here, but I've made it a phantom 0. That's on purpose. And yeah, this line brings down the equal sign. But now I got negative 71 plus 3, which is negative 68. If you struggle with doing those types of additions and subtractions, just use your calculator. It will tell you, it knows how to do that type of addition and subtraction, okay? But now I've got negative 4x equals negative 68. But I don't want 4x's, I want 1x's, right? So I need another principle of equality here. And I'm going to show the division a little bit different than I did on the bell work. I'm going to show it as a fraction line. Remember, fraction lines are still division, right? So I'm dividing by -4. Now, be careful on this. I am going to divide by -4, but here's a mistake that we often see right here. Students would say you'd add 4 to both sides, and then you get x equals, I don't know, like -64, something like this. Here's the problem with this, is -4x is not a like term. That goes back to our last unit. -4x and +4, they're not like terms that you can add together. When you use addition and subtraction, you have to have like terms to add and subtract. So see, even above with the -3 plus 3, I wasn't adding this 3 to the -4x. I was adding it to the -3 because these constants are like terms that I am able to combine, okay? So don't do this. Please don't do this. It's a pretty big mistake. It's going to throw you way off, okay? What we need here, like I was saying before, is to divide by -4. But since it's a principle of equality, if I do it to one side, I have to do it to the other side. Now that -4 divided by -4 is 1, so that's where we get the 1x. So I'm showing the 1 here. I'm not just crossing this out. This isn't saying I'm not even saying I'm canceling in this out. I'm just making it a phantom 1, okay? I mean, right now it's a 1, but it'll become a phantom 1. Then in my calculator, I do -68 divided by -4, which is 17. That's positive. And now that I got 1x equals some number, now I can make that 1 a phantom 1, okay? So this should be our solution, but again, I do want to check just to make sure it is. So I go back to my original equation, -4x minus 3, and this should equal -71, okay? But right now, that's the equation, but I'm going to replace x with 17 because I'm pretty sure if I replace x with 17, I'm going to get a true statement, okay? Now, before I start the work, and this is a question mark over the equal sign, when I do -4 times 17 in my calculator, I'm expecting this to be -68, right? Because remember, this -68 was part of the work. And when I do -4 times 17 in the calculator, I do get -68. Okay, now I will subtract the 3, and -68 minus 3 is -71, just like we expected from the beginning, okay? This is a true statement, which means that I can box in my answer, x equals 17. Yeah, that's the solution. Because it makes the original equation a true statement, just like we checked. This one has fractions, but the process is still the same. So now just the numbers are fractions instead of whole values. But our principles of equality, yeah, once again, it's just going to be the same thing, okay? So I'm going to go into this equation, and I'm going to use the principle of equality. And I'm using this principle of equality to make this plus 10/3 a 0, okay? So I don't want anything added or subtracted to my x's. Right now it's adding a 10/3. So I got to get rid of that. And by get rid of, I mean make a phantom 0. So I'm going to subtract it from itself, okay? That's 10/3 minus 10/3. But if I do it to one side, I got to do it to the other side as well. All right, so 10/3 minus 10/3. That's going to 0 out just like we planned. I'm going to drop my 1/4 x, which now equals, remember this line brings down the equal signs, now equals, so I go to my calculator and I just type this in. And I'm using the fraction button as I do this. So that's 13/6 minus 10/3. And I get -7/6. -7/6, okay? So this is my new equation. And again, it's just one term compared to another term now. But once again, I got a coefficient of x that's 1/4. I don't want a 1/4 x. What I want in the end here is 1x. So once again, what do I got to do to 1/4 to make it a 1? I got to divide it by itself, which is 1/4. Anything divided by itself is 1, just like we're seeing here. And again, there's a diagonal 1 right here. Just kind of fixed it right there. Okay, but if I do it to one side, I must also do it to the other side as well. Divide by 1/4. So on my calculator, -7/6 divided by 1/4, and I'm using the n over d button there. And the calculator tells me that this would then equal -14/3. Okay, so again, I got 1x. My coefficient of x is a 1. And it equals a number, so I'm just going to now make that a phantom 1 to make this look pretty, okay? The 1's still there, by the way. You just can't see it. Now that I have that, I'm going to go back to my equation. which was 1/4 x plus 10/3, and this needs to equal 13/6 if we're going to get a true statement, okay? So right now, I say x, I'm pretty sure x here is negative 14/3. So I'm going to replace x there with negative 14/3. And we're going to check for truthfulness, okay? So in my calculator, I got 1/4 times negative 14/3. I push enter, and it gives me, right here, remember there's a question mark, by the way, but this multiplication gives us negative 7/6. And again, that we were expecting this because it was part of our work here, the negative 7/6. Now I will add the 10/3. And again, I'm just using the calculator to do this. Please use the calculator. There's no reason not to, and it will do this work for you. In fact, it enjoys it. It's kind of weird, but plus 10/3, enter, and I get 13/6. Well, that does actually equal 13/6. That's a true statement right there. Which means that this value we found, x equals negative 14/3, yeah, that's the solution. All right, this one's going to work pretty much the same way. You guys try this one out. Take a minute, try this one out, then we'll go over it, okay? So, idea here is the same. Again, we're just dealing with fractions, but the calculator will do the fractions for us, so we don't have to actually do any changing the denominators, forcing them to be the same, anything like that, okay? So, once again, this plus 15/4, I got to make it zero out, so I'm going to subtract 15/4 there. But if I do it to one side, I got to do it the other side, okay? So that will zero that out just as planned, and then this will drop my 3/2 x, which now equals, remember this line brings down the equal sign. In my calculator, I did 3/4 minus 15/4 while you guys were working on that, and I got negative 3 there. Okay, now that I got 3/2 x equals negative 3, I don't want a coefficient that's 3/2. I don't want anything but a 1. So that's kind of my goal here, is to make this 1x equals something else, right? So how do I make a 3/2 a 1? Again, you're just dividing it by itself, divide by 3/2. Okay, but if you do it to one side, make sure you do it to the other side as well. So negative 3 divided by 3/2. And while you guys were working, I did this, and when I put it in the calculator, I got negative 2. Okay, so I got 1x equals negative 2. And again, I'm going to make that a phantom one. I don't want to have to look at that. Okay. Now that I got x equals 2, let's go back to the original equation, 3/2 x plus 15/4. This should equal, if we've done this right, 3/4. Okay, so I'm replacing the x with negative 2 here. And all I'm doing is checking for truthfulness. Okay, so there's my question mark. 3/2 times negative 2, well, that's just kind of what we expected there with the negative 3, right? Now I'm going to add the 15/4, which when I do that, I get 3/4. Okay. And 3/4 does equal 3/4, that's true. Which means that x equals negative 2, well, that actually was the solution. Okay, and I box this in with confidence because we did check, and you should be checking these, okay, just to make sure it's true. Remember, we see these values, like after the multiplication, we got this negative 3. That was part of our work right here. And then when I did negative 3 plus 15/4, we actually got the answer. But while it took 2 principles of equality to solve or find the solution here, it took 2 operations as well in order to check to see if it was true. This last one here is the same. It's pretty much the same idea. Like I got the n over 5, and that's not a problem, by the way. It's just after I get rid of that negative 4, and by get rid of I mean zero out. After I do that, after I zero out that negative 4, all I'm going to be left with is this n over 5, okay? So it'll equal something, just we're not sure yet what it is. So to make that minus 4 or negative 4 0, I would have to add 4. But if you do it to one side, you're going to have to do it the other side as well, okay? So negative 2 plus 4, that's going to be a positive 2. If you're not sure how I got this, put this in the calculator, negative 2 plus 4, okay? Now this 2 equals n over 5. This is a kind of like a problem that we saw in the last lesson. Remember, that's n divided by 5. So if I want to make that just an individual 1n, which I do, then I'm going to have to multiply this by 5. Okay, and again, it's kind of like 5 over 1, which allows me then to make that a 1. Remember, That diagonal right here is a 1. 5 divided by 5 is 1, okay? But then I got to do 5 times 2, because whatever I do to one side, I got to do the other side. 5 times 2 is 10. So I got 1n equals 10. And now that I got 1n equals something, I'm just going to make that coefficient of n 1, a phantom 1. Now, some of you prefer to write it like this, and that's fine if you do. This would just show like n equals 10. This is the same thing. But, as usual, I just want to check to make sure this would actually be a true statement. Okay, so I'm looking for negative 2. It should equal n over 5 minus 4. Okay. Right now, we're pretty sure the n here is 10. So I replace the n with 10. Put a question mark over my equal sign because I'm just checking for truthfulness. And 10 divided by 5 here is 2. Okay, and that was part of our work. And then 2 minus 4, there is negative 2. So negative 2 does equal negative 2. That's true. Which means that our original 10 equals n, or n equals 10, same thing. Again, that's a solution to this equation. Okay, so this is kind of our last problem for this one. Remember, the objective here is to make phantom zeros first, and then you're going to make phantom ones right there like that, okay? Of course, it's not a phantom one initially, but we made it a phantom one eventually, okay? So yeah, with the two principles of equality, generally it's the addition or subtraction principle of equality first, and then you would use the division or multiplication principle of equality to make that coefficient of whatever the variable is a phantom one.